Dear students, in previous class we learned about properties of triangles, formulas and problems. In this class we will learn some more problems on properties of triangles. Area of a triangle. Objectives. On completion of this period, you would be able to write trigonometric ratios of submultiple angles and find the area of a triangle. Recap. Sine rule. In any triangle ABC, A by sine A equals to B by sine B equals to C by sine C equals to 2R. Next, cosine rule. In any triangle ABC, A square equals to B square plus C square minus 2BC cos A, and B square equals to A square plus C square minus 2AC cos B, and C square equals to A square plus B square minus 2AB cos C. Semi-perimeter. The semi-perimeter of a triangle ABC is A plus B plus C by 2 and will be denoted by S. So S equals to A plus B plus C by 2. To find the sine A by 2 in terms of ABC, we have cos A equals to B square plus C square minus A square by 2BC. Also we have cos A equals to 1 minus 2 sine square A by 2. Hence 2 sine square A by 2 equals to 1 minus cos A. Here in place of cos A we are substituting the cosine rule, that is B square plus C square minus A square by 2BC. And if we took the LCM is 2BC, and 2BC multiplied with 1, so 2BC minus is multiplied with the numerator of the second term, so we get minus B square minus C square minus into minus plus A square. So we can write that is A square minus B square minus C square minus 2BC. And if we write in the factors form, we can write it as a C here A plus B minus C into A minus B minus C all divided by 2BC. Here if we multiplied, we will check whether the above step is coming or not. That means numerator is equal to these factors or not. So a into a square, a into b minus ab, and a into c minus ac. Next b into a plus ab. So plus ab minus ab get cancelled. B into minus b square. So minus bc. Next c into a ca. So here minus ca. And minus c into b minus bc. And in before also we have minus bc. So minus bc minus 2bc. And multiplying with minus c means minus into minus plus bc, and minus into minus c plus c square. So we here 2bc means a square minus b square minus c square. So yeah, now I got the point. See here, actually the printing mistake. See, after LCM in the numerator we have 2bc. So 2bc minus b square minus c square. If you observe these three terms, if we took the minus common from these three terms, we have b square plus c square minus 2bc. So b square plus c square minus 2bc can be written as a b minus c whole square. So here the bracket is missing, so that we are getting confusion. So a square written as it is, and minus already taken common, so it is b minus c whole square. So here the bracket is missing, that's why we are confusing in the how the factors came. So b minus c, it is in the bracket, so here bracket is not printed. So now b minus c considered as a b, then it is in the form of a square minus b square. A square minus b square means a plus b into a minus b, so that it is divided in two factors. It is written in the two factors. Next step, if we observe, here two factors are there, and in the first factor we are adding c and subtracting c. So the part is becomes a plus b plus c minus c means minus 2c. And here bracket is not printed, so we have to take brackets, or we have to put the brackets for first factor and second factor. And come to the second factor, here we are adding b and subtracting b. Then it is becomes a plus b plus c, and minus b we can write minus 2b. So this is also we have to keep in the bracket. And a plus b plus c equals to 2s. So in place of a plus b plus c, we have to write 2s. So 2s minus 2c kept in a bracket. Here bracket is not printed. And in the second factor also same. In place of a plus b plus c, write 2s. So it is 2s minus 2b. And it should be in a bracket by 2bc. if we take 2 common from first factor and second factor, we get 2 of s minus c into 2 of s minus b. So in the denominator also we have 1 2. So 2 get cancelled, and one more 2 is there in the numerator. So write it is as it is, 2 into the remaining factors s minus b into s minus c by bc. So now this is 2 sine square a by 2 equals to 2 into s minus b into s minus c by bc. So both sides we have 2, so 2 get cancelled, then therefore remaining is sine square a by 2 equals to s minus b into s minus c by bc. And if left side of the square is goes to the right side, it become a under root. So sine a by 2 equals to plus or minus under root of s minus b into s minus c by bc. Here brackets are not printed, but we have to put in a bracket because there are two factors. Since in a triangle a is always less than 180 degrees, therefore a by 2 is always less than 90 degrees, and consequently sin a by 2 is positive. We must therefore take the positive sign before the radical. Hence sin a by 2 equals to under root of s minus b into s minus c by b minus c. Here also brackets are not printed, so we have to put s minus b is in a bracket and s minus c also kept in a bracket. So take bracket, write brackets or put brackets for s minus b and s minus c also. Otherwise the meaning will be changes. So please remember and put them in a bracket. So two factors are in a bracket, and similarly sin b by 2 equals to under root of s minus c into s minus a by ab. Here also brackets are missed, that mean not printed, so keep them in a bracket. And similarly sin c by 2 equals to under root of s minus c into s minus a by ca. Next, to express the cosines of half the angles in terms of ABC. So how to do or how to express? So here given, look here, cos A equals to, from cosine rule we know, b square plus c square minus a square by 2bc. And also cos A is, we can write 2 cos square a by 2 minus 1. We already know this formula. We learn cos 2a formula, 2 cos square a minus 1. So this is came in the chapter compound angles. So from cos 2a we can write cos a equals to 2 into cos square a by 2 minus 1. Hence the right side of the minus 1, if we bring to left side, it is positive 1. So we can write 1 plus cos a equals to 2 cos square a by 2. So here we wrote 2 cos square a by 2 equals to 1 plus cos A. So both are exchanged means there is no change. Left and right both are changed means the part is as it is. Next, that equals to 1 plus. So cos A means we are applying cosine rule. That means we are writing b square plus c square minus a square by 2bc. And if we took the LCM of the two terms, then we have 2bc is the LCM and 2bc is multiplied with 1. So 2bc into 1, 2bc plus b square plus c square minus a square. Next, see here, observe the first three terms, that is 2bc plus b square plus c square. So it is in the form of a square plus b square plus 2ab. So we can write b plus c whole square. Here brackets are not printed, so we have to keep b plus c in a bracket. So whole square minus remaining a square is right as it is, a square. So consider b plus c as a and minus a as a b. So it is in the form of a square minus b square. So a square minus b square means a plus b into a minus b. So we can write it as a two factors, that is b plus c plus a into b plus c minus a whole divided by 2bc. And the first factor is a plus b plus c. So here the brackets are not printed, so we have to keep it in a bracket. And come to the second factor, there is not positive a, so we are adding a and subtracting a to the second factor. Then we have a plus b plus c minus a means minus 2a. So this second factor also keep in a bracket. Here bracket is not printed. And next step, in place of a plus b plus c, we can write it is a perimeter of the triangle, so it is indicated as a 2s. So 2s into, and second factor also we have a plus b plus c. So in place of a plus b plus c, we can write 2s minus 2a. So 2s minus 2a by 2bc. 2s into, if we took 2 common from second factor, so it is 2 into s minus a. So in the numerator and denominator, 2 get cancelled. The numerator we have 2, another 2. So 1 2 is cancelled by new denominator. So another remaining 1 2 is there. So 2 into s minus a by bc. And here left side is 2 cos square a by 2. So 2 left side and right side also we have 2 into s. So 2 get cancelled. Then cos square a by 2 equals to s into s minus a by bc. The square is comes to the right side, then it is becomes under root. So cos a by 2 equals to plus or minus under root of s into s minus a by bc. So s minus a should be in a bracket. Here bracket is not printed, so you have to understand and keep in a bracket. Next, since in a triangle a by 2 is always less than 90 degrees and consequently cos a by 2 is positive, we must therefore take the positive sign before the radical. Hence cos a by 2 equals to under root of s into s minus a by bc, and cos b by 2 equals to s into s minus b by ca. and cos c by 2 equals to under root of s into s minus c by ab. So here we have to keep the second factor in a bracket because here bracket is not printed. Next, to express the tangents of half the angle in terms of ABC. So it is very simple, I think, because tan a by 2 can be expressed as a sin a by 2 by cos a by 2. So already we know sin a by 2 means under root of s minus b into s minus c by bc, and cos a by 2 also we knew just now. So under root of s into s minus a by bc. So under root of bc is in the numerator and denominator. So bc get cancelled, and that equals to under root of s minus b into s minus c by s into s minus a. So s minus b should be in a bracket and s minus c also in a bracket, and in the denominator s minus a is also in a bracket. Here brackets are missed, so we have to keep it in a brackets. Similarly, tan b by 2 equals to under root of s minus c into s minus a by s into s minus b. See, to remember which angle is we are writing to the left side, that side is coming in the denominator of the RHS. I'm saying for remember the formula. Or if you know the sin a by 2 and cos a by 2, by simplify we can write. So similarly, tan c by 2 equals to under root of s minus a into s minus b by s into s minus c. Here also brackets are not printed, are not kept, so we have to keep them in a brackets. So three factors should be in a brackets. For yes, there is no need to keep a bracket. It is a only single. So it should not. It is not compulsory to keep a bracket, yes, but remaining three factors should be in a bracket. Next, up to now we observed how to express the half angles of sine, cos and tan. Now let us see area of triangle ABC. To find the area of a triangle when given two sides and the included angle, given three sides. Second condition. First condition is given two sides and the included angle. The two sides are given means that in between the sides the angle is framed. Next, first condition we are taking when two sides and included angle given. Area of triangle ABC, that is delta, equals to half AB into sine C. Half AB into sine C. That equals to half BC into sine A. Half CA into sine B. So generally area of the triangle is half into base into height. See here, from triangle ABC, from diagram, the base is BC means the side BC is indicated as a small a because it is opposite to angle A. So half into A we can understand. So height here, AD is a height of the triangle ABC. So AD is perpendicular to BC. So actually we have to write half into A into AD. So AD is we are converted as a B into sine C. How it is possible? See, if you observe triangle ADC, sine C equals to opposite side by hypotenuse. Opposite side is AD, and AD by AC means small b. So AD by B equals to sine C. Then AD equals to B into sine C. So that's why we are written in place of AD B into sine C. So now I think you got the point. So therefore area of the triangle equals to, similarly, half into BC sine A, half into CA sine B also. So simple to remember is half AB, small a is side, small b is side. So C is not there means sine C. Like that we have to remember the area of the triangle ABC. And similarly we can write half BC sine A and also half CA sine B. Next, the proof is given. I already explained you. So draw AD perpendicular to BC. Area of triangle ABC of base into height of BC into AD of BC into AC sine C of AB sine C. Since from triangle ADC sine C equals to AD by AC. Similarly, the other two can also be proved. Given ABC, A comma B comma C, and A equals to under root of S into S minus A into S minus B into S minus C. So area of triangle ABC equals to, your area of the triangle is, we already knew, half into AB into sine C. Area of a triangle is indicated as a bar, or we can write simply A. So half into AB into sine C. So in compound angles we know sine A formula is 2 sine A by 2 cos C by 2. Similarly, sine C can be written as 2 sine C by 2 cos C by 2. So 2 get cancelled and remaining is AB into sine C by 2 into cos C by 2. AB into, we already know sine C by 2 can be expressed as under root of S minus A into S minus B by AB, and cos C by 2 can be written as under root of S into S minus C by AB. That equals to, in the denominator under root of AB, under root of AB is becomes AB. So numerator also have product of AB. So AB get cancelled. So remaining is under root of S into S minus A into S minus B into S minus C. In the numerator we have two roots, and in between the roots we have product. So put them in a one under the root. So because the product is there means root A into root B, we can write root AB. Like we are here, two roots is, instead of two roots we are keeping one root and multiplying the factors. So under root of s into s minus a into s minus b into s minus c. Therefore area of the triangle can be expressed as a under root of s into s minus a into s minus b into s minus c. That means sides and generally it expressed in a sides. So we have to know. Generally we knew area of the triangle means half into base into height, but here without height we can find out the area by using this formula, that is under root of s into s minus a into s minus b into s minus c. Very interesting. Next, area of triangle ABC. So half into base into altitude means height, half into b into c into sine a, and half into bc into sine a can be expressed as a by 2r. So abc by 2 into 2 4r. So abc by 4r, then abc equals to 4r into area of the triangle, or 4r into a bar, or we can simply write 4r into delta also. So or 4r into area of the triangle. Next, problems. In any triangle ABC, show that tan a by 2 into a bar equals to s minus b into s minus c, and tan b by 2 a bar equals to s minus c into s minus a, and here the printing is mistake, because tan a by 2 equals to s minus b into s minus c by area of the triangle, and like similarly tan b by 2 equals to s minus c into s minus a by area of the triangle, and tan c by 2 equals to s minus a into s minus b by area of the triangle. So this is the question. The print is wrongly came, so that it is looking like that. So that area of the triangle should be in the denominator. Next, see how the proved tan a by 2 equals to, we already know, under root of s minus b into s minus c by s into s minus a, that equals to s minus b into s minus c, and again we are multiplying and dividing s minus b into s minus c. So in the denominator also s into s minus a into s minus b into s minus c. Numerator and denominator we are multiplied s minus b into s minus c. So because there is no change if we multiply to numerator and denominator, and s minus b into s minus b means s minus b whole square, and s minus c into s minus c means s minus c whole square. So in the numerator square root get cancelled and one single factors are remains, that is s minus b into s minus c. Here brackets are not printed, so we have to keep it in a bracket. And in the denominator under root of s minus a, s into s minus a into s minus b into s minus c. Here s minus b and s minus c are also not in a bracket, so we should keep it in a bracket. And in the denominator, in place of that, we can write area of the triangle. So finally we can write tan a by 2 equals to s minus b into s minus c by area of a triangle. So similarly, the other two can also be proved. Next problem. In any triangle ABC, show that cos a by 2 equals to s into s minus a by area of a triangle. And here we have to denote the area of the triangle by delta. So here a bar is given, but for our convenient, delta should be, we can express for area of the triangle. So cos a by 2 equals to s into s minus a by delta. Sorry, not cos, cot, cot, cotangent. So cot, and cot b by 2 equals to s into s minus b by delta, and cot c by 2 equals to s into s minus c by delta. Here delta means area of the triangle. That should be remember. See the proof how we show. Cot a by 2 equals to under root of s into s minus a by s minus b into s minus c. In the numerator and denominator, we are multiplying with s into s minus a. So we get in the numerator s into s minus a twice, and in the denominator s into s minus a into s minus b into s minus c. So twice the product means we can write s into s minus a whole square. So square root get cancelled. So in the numerator, after getting cancelled, we have s into s minus a by the denominator. If you observe, it is equal to the area of the triangle, so delta. Therefore, cot a by 2 equals to s into s minus a by delta. Similarly, the other two can also be proved. Next problem. In any triangle ABC, show that cot a by 2 plus cot b by 2 plus cot c by 2 equals to s square by delta. So delta means area of the triangle. Here I am saying delta, but here given is a bar. So a bar you can also write, or you can take delta, no problem. So don't confuse. A bar means area of the triangle and delta means also same. Here to show that, take LHS, that is cot a by 2 plus cot b by 2 plus cot c by 2. And cot a by 2 we can express s into s minus a by delta. Already we know the formula. And cot b by 2 we can write s into s minus b by delta. And cot c by 2 we can write s into s minus c by delta. And in the three terms we observe s by delta is common. So take common s by delta. The remaining is s minus a plus s minus b plus s minus c. Then s by delta of 3s minus of a plus b plus c. Here a plus b plus c should be in a bracket. Here bracket is not printed, but you have to assume. Next, s by delta into 3s minus a plus b plus c means 2s. So 3s minus 2s means s, and s into s square by delta. So this is the RHS. Hence we showed. Next problem. In any triangle ABC, show that a plus b plus c into tan a by 2 plus tan b by 2, it should be in a bracket, and equals to 2c into cot c by 2. So take LHS, that is a plus b plus c into tan a by 2 plus tan b by 2. So here two factors, a plus b plus c we can write 2s, and tan a by 2 is expressed as a s minus b into s minus c by delta, plus tan b by 2 we can write s minus a into s minus c by delta, and both the denominators have same in the second fractions. So write 1 delta as a LCM, and the remaining is s minus b into s minus c plus s minus a into s minus c. So in the numerator, s minus c is we can take as a common. So s minus c, if we took the common, the remaining part is s minus b plus s minus a. So 2s by delta into s minus c into, here s plus s is 2s, and if we took minus common from minus b and minus a, we can write minus of a plus b. 2s by delta into s minus c. Here s minus c should be in a bracket is not printed, and 2s we can express it as a plus b plus c, and minus of a minus b. So here minus is multiplied with a plus b, we get like this, and it should be in a bracket, and plus a plus b minus b get cancelled, and c is there. So next step is 2s into s minus c into c by delta, and 2c if you write separate, and remaining is cot c by 2. Remaining part is replaced with cot c by 2, because cot c by 2 is s into s minus c by delta. So this is how we proved. Next question. In a triangle ABC, sigma of a into cos square a by 2 equals to s plus delta by r. So take LHS, is sigma of a into cos square a by 2 equals to sigma of a into 1 plus cos a by 2. So by 2 if we took common, and sigma of a into 1 plus cos a. Here 1 plus cos a should be in a bracket. Here bracket is not okay. And we are expanding the sigma. That means from short form to we are writing full form. And I already told you sigma means cyclic summation. Here in a cyclic triangle we have A, B, C. So like that. That means the summation is in the three terms. The given, which is short form, should be considered as a one term, and we can express sum of another two terms from the given by given term. We are expanding some more two terms. So it is easy. A into 1 plus cos a, plus after a b comes, so b into 1 plus cos b, and after b we can write c, so c into 1 plus cos c. So this is the full form of sigma here, and off into a into 1 a, so here multiplied with which are in bracket, and after that we get a plus b plus c plus a into cos a, b into cos b plus c into cos a. See here, the first term a into 1 a and a into cos a. The second term also same, b into 1 b and b into cos b. Like that we get this, and that equals to 1 by 2 into, here brackets is missed, so you should keep the brackets. A plus b plus c means 2s, so 2s, and after that plus small a means from sine rule we can write 2r sine a, so cos a as it is, plus small b means 2r sine b cos b as it is, and small c 2r sine c cos c, 1 by 2 into 2s plus 2 sine a cos a means sine 2a, that is r into sine 2a plus r into sine 2b plus r into sine 2c. So half into 2s plus r into sine 2a plus sine 2b plus sine 2c. We have in any triangle sine 2a plus sine 2b plus sine 2c equals to 4 into sine a sine b sine c, half into 2r plus 2s plus r into 4 sine a sine b sine c. So this is already we proved in transformations, so from that, or you can consider it as a formula, sine 2a plus sine 2b plus sine 2c equals to 4 sine a sine b sine c. This is already we proved in the transformations. So 1 by 2 into 2s plus, if we took the 4 with r, so 4r into sine a means from sine rule we can write a by 2r. Similarly sine b, b by 2r, and sine c, c by 2r. So half into 2s plus abc by 4r, 4r get cancelled, remaining is 2r square. So if you multiplied with 1 by 2 in bracketed terms, so it is equals to s plus abc by 4r square, then s plus abc is, we can write 4r into delta, so 4r cancelled, then delta by r, so s plus delta by r, this is RHS. Summary: in this session you learned finding the area of triangle when two sides and angle between them are given and three sides are given, and quiz. So area of any triangle is, so we already discussed all of the above, that is you can easily observe. Next, in any triangle ABC, B equals to C equals to angle A equals to given R, then triangle is, so you can find out. Next, some questions are asked frequently, so do that questions, and if you have any doubts you can ask me. And before opening the video you have to open the PPT in another device. Sometimes in a video some steps or some screen may not be clear, so to overcome that problem, if you open the PPT in another device you can see the PPT and observe the video or listen the video. You can easily understand what I am saying and what is the concept on video. Okay, so do the exercise problems. Thank you.